just in case. All right. Take a roll later. Okay, so I think with time, probably won't do all of these. Since we spent time talking about all that. Let me throw a couple of these out there. Jarrett, can I have you do the first one here? Or not first one, but B. Kyla, can I have you do C? Kayla, I'm going to have you do D. Sophia, I want you to do E. I'll come back to some more people later. So Jarrett, what do you think about B there? How do we say that?
Log of 4 of 12.
Close. Got one word off here. What do we call this number right here? Say what?
They multiply each other.
What's this number called?
Subscriptor?
It is a subscriptor, yeah, but that's not what it's called.
It's a base.
So how would you say that?
Log base of 4 of 12.
Yeah, you get to be ofs, so just log base 4 of 12, right? And what does that mean?
4, like, of a number equals 12.
If I said 4 of a number equals 12, that's what that would mean to me.
Like there would be like 4 exponent something equals 12.
So 4 to some exponent would equal 12, right?
Yeah.
4 to what power would equal 12? 4 to raised to some power equals 12. That's okay. And then what is 4 to what power is 12?
I don't think there is one, is there?
Is there not one, or is it just not easy to find?
I think it's just not easy to find.
Right, so 4 to the first power is?
4 to the first power is 4.
Right, 4 to the second power is?
16.
16. So this number is somewhere between 1 and 2 because it's somewhere between 4 and 16, right? We just don't know what it is, right? So this would be one of those cannot be easily found problems, okay? So again, there's this difference between not existing and not being easy, right? So, all right, thank you, sir. All right, Kyla, what about C? Natural log of 10, great. Oops, I didn't say a word. Natural log of 10. Okay, and that meant, try again, Kyle. It's not 10 to the 10, or not 10 to the whatever equals 10. What's natural log? What's our base? Yeah, base E, so try that again. How would you say that? There you go. E to the what is 10, right? E to the what power is 10, so what is the natural log of 10? It's not 1. How are you getting that? How'd you get 1? Right, 10 to the 1 is 1, but remember, this is not base 10. This is base E. If it said 10 to the what is 10, then we'd be, yeah, 1 would have been our answer. Right? Or E is like 2.72 something, right? So how do we figure out what the natural log of 10 is? So normally we would say it's not easily found, but it actually is pretty easy to find. We have access to that number. How do we figure out what the natural log of 10 is? Ah, yes. Let's look at it right here. Okay. You guys should all be figuring out what the natural log of 10 is. Okay. So here's thousandth. So it's not that we can find it easily, but it took me about half a second to type it in my calculator. That sounds pretty easy. Okay. So 2.303. Okay. We have no idea how to figure out 4 to the what is 12 on our calculator yet. Dun, dun, dun. All right, Caleb. What do you hear?
Okay. Log base 10 of -2.
All right, so Caleb said log base 10 of -2, which is right, but I don't like
Do we
it.
not need the 10?
We do not need the 10. What did we just say?
Log base 2.
Log
Log of 2.
of -2. All right, because we just need to know that log means base 10. We don't want to write it. We don't want to say it. I want to be as lazy as possible. So anytime you see log, it's just log, right? The log of -2. But we need to know, like Caleb said, that means base 10. So then what would it mean, Caleb?
10 of an exponent equals -10.
Okay, and then what would log of -2 equal?
It doesn't.
It does not exist. Right? You cannot take the log of a negative number. Not okay. Right? Can't multiply tens by each other and never get a negative answer. That doesn't make sense. Okay. All right, Sophia, you're next. Let's see. Addison, can you do F? And Anthony, can you do H when we get there? All right, Sophia. All right, log base 0 of 9. Good. And what's that mean, Sophia? 0 to the what power is 9, right on? And what is that equal to? What is log base 0 of 9 equal to? Yeah, that also does not exist, right? Can't multiply 0 by itself a bunch of times, right? 0 times 0 times 0 times 0 times 0. Are you ever going to get 9 out of that? Of course not. We're always just going to get 0, right? So no log base 0. Just, again, what are we not allowed to do with log? Log is an operation, something we do to numbers. Well, we can't take logs of negatives. We can't figure out the log base 0, right? So kind of just looking at those restrictions on this operation. Cool. Addison, what about F here? How do you say that? You with me, Addison? Calling in Aiden. All right, what you got, Aiden, for F?
Log base 1.
Log base 1 of 13. Okay, what's that mean?
1 something power.
Okay, 1 to something power equals 13. So what is log base 1 of 13 equal to? Get your calculator out of your hand. Get your calculator out of your hand. One to some power is 13. Right? Yeah, does not compute. Right? Can't multiply 1 over and over and over again. Always just going to get 1 as an answer, right? That doesn't work. So no log base 1. Right? Cannot do that. All right, Anthony, last one. Log of 32. Guys. Time. What's that mean? So E comes from the natural log. What's log? What's the base on log? Yeah. Well, think about what you just said, right? 10 equals 35. 10 doesn't equal 35, right? But, right, how are we saying this? 0 to the what power is 9. E to the what power is 10, right? 4 to the what power is 12. So how would you say that? I'm not asking you to know the answer. I want you to ask the question, right? 4 to the what power is 12. E to the what power is 10. Yeah, there we go. And we got to ask the question before we can answer the question, right? So then, what is the answer to that, right? What is log of 35? See, now he's touching his calculator, right? That's what he shows. Because we can do logs, we can do natural logs on our calculator, right? Yeah, Tion, right? 1.544. Right, there you got, Anthony? Okay. And again, you always check that way, right? What is 10 to the 1.544? You should get something really close to 35, right? Does your answer work, right? You can always check it back real quick. Okay, so just seeing those again, just, what doesn't work, what can't you do, right? Can't take a log of a negative. Base can't be 0, 1. The base also cannot be negative. Okay, so I can't have like log base -3, that doesn't work. And you also can't have a 0 in here. I think we saw one of those yesterday where we had a 0 in the argument. That doesn't work. So this number inside of here, you guys don't really need to know this, but this number inside of here is called the argument. So the argument here is 13. The base is 1. The argument is 13. It's just saying what's the log of, right? Of number is called the argument. All right, so how do we do the ones that we haven't been able to do? Again, it's the difference between impossible and difficult. How do we do the difficult ones? Okay, so we saw earlier log base 4 of 12 meant 4 to the what is 12. We weren't able to figure that out. We can kind of say, well, it's somewhere between 1 and 2, but we don't know. Okay, so what this is called, the change of base property, and just has a couple rules that actually we were just talking about. As long as A and B are positive numbers, and then B can't be 1, right? We were just talking about like numbers that couldn't be in here, no negatives, can't have 0, that number there can't be 1. As long as those numbers follow those rules, we can take that log of any base, so log base 4 of 12, and rewrite it as a ratio of common logs or a ratio of natural logs. It does not matter which one you do. My habit is to do this one for whatever reason. I have no idea why. Okay? I just use this one. But it does not matter which one you do. Okay? You cannot do like a mix match. I can't do log of A divided by natural log of B. That's not okay. If you're going to do log, it's got to be log. If you're going to do natural log, it needs to be natural log. So we can rewrite a log of any base into a ratio of log of common logs or ratio of natural logs. And we know how to do this in a calculator. I can type this into a calculator and it will spit out an answer for me. Whereas we don't know how to type that into a calculator. So log base 4 of 12 means 4 to the what is 12. And that can be found by rewriting it as a ratio of log of 12 over log of 4. Now really the only thing you can do wrong here is to put the numbers in the wrong spots. Right, where does the 4 go? Where does the 12 go? Well, it's pretty nice because the base of the logarithm always goes to the bottom of the fraction. So the base goes to the bottom. And if you can remember that, then the other number must go to the top. Okay, base goes to the bottom, the other number must go to the top. Okay, so log of 12 divided by log of 14. As you're typing in your calculator, pretty much the only thing you got to worry about is make sure you close this parenthesis here around that 12 before you go and do the division. Okay, so I'm going to do log of 12 divided by log of 14. So function log 12, make sure I get on the other side of my parenthesis on this one, divided by function log 4. I always look over at that left side, make sure it looks like the way I typed it, or that's what I wrote on my paper. Make sure it's displaying the same way. And we see the answer here. Let's go ahead and round that to the nearest thousandth, like we were yesterday. So 1.792. Remember the question. 4 to the what is 12? So 4 to the 1.792 is pretty darn close to 12. Okay? So we can actually find that value. Okay? And you can check your answers really, really fast. Does my answer actually work? So 1.792 is our exponent here. So this is how we use what's called the change of base property to go from random base to a ratio of common logs or a ratio of natural logs. I'm going to do another one with you guys, and I'm going to have you guys start doing some. So log base 20 of 5 means 20 to some power is 5. I'm going to rewrite that as a ratio of natural logs this time just to show you that it works. Okay, so the natural log of some number over the natural log of some other number. My base always goes to the bottom. So the 20 is going to go to the bottom. So the natural log of 20 is going to be at the bottom. That means the natural log of 5 has to be on the top. Make sure I close that second parenthesis as I type it in, but otherwise it's just typing. So natural log of 5 divided by the natural log of 20. Remember, no mixing and matching. If you're going to do natural log, you need to do both natural logs. If you're going to do common log, they need to both, oops, I'm about to do it. They're going to need to both be common logs. So I got 0.537. Remember, the question was 20 to the what is 5? 20 to the 0.537 is 5. All right, we're getting something really close to 5. Okay. So this is how we use change of base to find those hard to find logs. So I've set this up, pretty much like we were doing yesterday. I've taken out the how do we say it part, focusing on the what does it mean, how do we rewrite it, and what's it equal to part. Okay. Let's go. Tion, can I be the first one? Jubal, and then Brian. Bunch of L's here. Tion, what does log base 4 of 40 mean? What's log base 4 of 40 mean? Okay. Uno momento. Make sure when you type in your answer, put it in public chat, please. That's how we say it. What does it mean? Should give me a statement like that. 4 to the what is 40? Okay. And how can we rewrite that as a change of base, a ratio of logs? Log base 20 of 5 was the natural log of 5 divided by the natural log of 20. Log of 40 divided by log of 4, okay. And what's that equal to?
This
This better be equal. This better exist. Because I know 4 to the second power is 16 and 4 to the third power is 64. So 4 to the some power better be between 2 and 3. So it better be 2 point something. Right? I can't take logs of negatives. I can't take 4 to some power and get negative 40. I can't take 0 to some power and get 40. I can't take 1 to some power and get 40. I can take 4 to some power and get 40. Just some weird power. Right, there you go, 2.611 or 2.661. Okay. And again, you always check that, right? Does my answer actually work? 4 to the 2.661, there's 40, right? Now, that'll check. Okay, so Aiden had a really good question, all right, which actually nobody's asked today, which is surprising. So can log of 40 divided by log of 4 be rewritten as log of 10? What's log of 10 mean? What does that mean?
Oh yeah, 61.
What's log of 10 mean? What's log of 4 base? Get your fingers off calculator. What's log of 10 mean? If log base 4 of 40 means 4 to the what is 40, what does log of 10 mean? Where are you getting a 1 from? What's the base on log?
Based on log.
10. So what's it mean? You're too busy trying to answer the question rather than ask the question. I'm asking you to ask the question. Log of 10 means what?
Why am I so lost?
I don't know.
Wow.
Base is 10 means 10 to the what is 10.
Oh. So 10 to the...
So log of 10 is equal to 1.
Okay.
Right? Did this equal 1?
No.
So can we do that math? No. Okay. So yeah, you cannot do this. Can't take logs written as fractions and reduce the fraction because that's not a 40. It's not a 4. Right? It's saying what's the exponent on 10 that gets me 40 and what's the exponent on 10 that gets me 4. That's not 40 and 4. Right? This is a number that we don't know. Right? 10 to the what power is 40? That's a question. Right? The answer to log of 40 is some gross decimal. Right? And the answer to log of 4 is also some other gross decimal. Right? We can't just reduce those two things and get something nice out of it. Okay? So yeah, it's really, you have to see that as a number. Log of 40 is a number, but it's not 40. It's just like I said, the square root of 40. Right? That's not 40. Right? I can't divide the square root of 40 by 8. There's not actually an 8 in the square root of 40. It's something completely different.
Yeah.
And we're doing something to that 40. It's not just a 40. Okay? But good question. Okay. Oh, all right. Jubal's busy answering stuff. All right, Jubal, you said 2 to the what is 45. Whoops. All right, so yeah. Nope. That's big no. You said log of 45 divided by log of 2. Cool. And 5.491. So we say, does it actually work? 2 to the 5.491. 2 to the 5.491. Yeah, it's really close to 45. Right? So we found it. Cool. Good job, Jubal. All right, Brian, last one. Thanks, Joel.
Log base 1/3 to the what is 1/5 or 1.5.
Okay, so I like part of what you said. I don't like the other part. So you shouldn't be saying log base. You should just be saying 1/3 to the what. Right? So 1/3 to the what is 1 point.
Yeah,
right?
1/3 to the what
Okay. Then how do we change that base?
and then what was that?
I want this part.
Log 1.5 over log 1/3.
Okay, log of 1.5 over log of 1/3. Good. What do you get?
And then negative 0.369.
Okay, so does it work, right? Does negative 0.369 work? So 1/3 to the. So when you type fractions into a calculator, make sure you're using parentheses. So 1/3 in parentheses, caret negative 0.369. That's really close to 1.5. Okay, good job, Brian. Okay. This is how we use change of base to evaluate those logs that we couldn't do yesterday. So now there are no more can't be easily founds. Okay? You can find them all except for the ones that don't exist, right? So we've eliminated the easy, difficult thing. Now there's just ones we can do and then ones we can't do. See, Jewel, be good. Okay? So really where we're heading with this is this idea of solving these equations, right? This is what we finished up on yesterday. I tried to clarify the instructions a little bit on this, about what I'm expecting. I want you to rewrite the equation into the other form in order to solve it. If you need to use change of base, then do. You won't always need to. And then, of course, just finish it up with a calculator if you need to. Okay? That first step should always be rewriting the problem. That I can't solve for x because x is in the exponent spot. So how do I get it out of there? Okay? And that involves getting it from one form of the equation to the other. So right now this is in exponential form. So this is in our a to the x equals y form. We need it to be into that logarithmic form, which is the log base a of y equals x. So where does my a go? If my a is here, where does it go? Okay, it goes down to the log base. Where did my x go? Oh, it went all the way across the equal sign. Where did my y go? It went into the argument. Okay, so switching all that stuff around. So I'm going into a logarithm, which means I know my answer is going to look like this. Log base something of something equals something. Like I need to go and fill in those spots. Right, each of those needs to be a number. I always start with the base of the power, because that's going to be the base of my logarithm. I just wrote log base 10. I'm not happy that I wrote log base 10. I'm going to fix that in a second. That x and that 17, they're going to switch sides. That 17 is going to come into the argument. The x is going to head off to the other side. We're going to see that now we've actually solved for x, because x is by itself, right? We've accomplished that first goal. We solved for x. We may not know what it's equal to as like a number yet, but we know that there it is. Log of 17 is equal to x. Okay? I really don't want you guys doing this. I don't want you writing log base 10. Okay? If you need to do that right now as kind of like a little pit stop, go for it. Okay? You get here and then, oh wait, I'm not supposed to write log base 10, and get there. But I'd really like you going straight to there. We don't write log base 10. We don't say log base 10. We just say log. We know that it's base 10, but we don't say it. We don't write it. Okay? Just the same way we don't say the square root with a 2 there. We say it. We know that it's there, but we don't write it. Okay? So there's x, right? This is what x is equal to. And I can use a calculator to figure that out. Okay. Function log of 17. 1.2304. I do need to round that 4 off, so I have to leave that 0 there to indicate to somebody that I did round down. So as far as what I want to see from you guys, I want to see your logarithmic equation, and I want to see what you got. Okay? At the very least, because I didn't have to do change of base because it was already base 10. Okay? If we have to do change of base, then there'll be more that you need to show me. Okay? You can always check your answer. 10 to the 1.230. right? You get something really close to 17. Really fast check. Okay, and I'm not asking you to do it, but you can do it for yourself. Just like, did I get the right answer? That way you can know if you need to be asking questions. Okay. So I had an exponential. I went to a logarithmic. That gave me x. Now I have a logarithmic. Notice how the x is trapped in the log. How do I get that away? Okay. How do I unlog? I unlog by converting it to an exponential. So I need to know what my log base is. This is log base e, because it's natural log. So I'm looking right there, and I see that little e that's down there. Right? So I have e to the some number is going to be equal to some other number. I got to figure out what's going to go where. Right? So I've got the x to deal with, and I've got this 12.25 to deal with. Those two switch sides. So the 12.5 is going to hop up to here. The x is going to jump down to there. So x, right? There's x. X is solved for. See, x is all by itself, right? That's our goal, solve for x. Okay? So we know what x is now. It's e to the 12.5, whatever the heck that is. Okay? Because e is 2.7 something to some big decimal or some big exponent. So, but now we can type it in our calculator. It's going to be some big long number. So make sure you know where your e button is. It's 12.5. All right, 268,337.26287. 268,337.287. Yeah, what am I expecting to see from you guys? You can convert the equation, and then you can evaluate it. Right? What work are you doing? Your work is all here. Right? That's all the work you did. How do I rewrite this? And the calculator took care of the rest. Okay? But I want you guys to be fluid here. If you can do this back and forth, you can solve the logarithms easy peasy. Okay? This is usually where people get stuck. How do I move the numbers to the right spots? So I'm in an exponential. That means I'm here. I need to get here to get x by itself. Always. All right. So what's it going to look like when I'm done? Just kind of general idea. Log base some number of some number equals some number. Where do those numbers come from? The base is always the base. The exponent and the answer always switch spots. So log base 6 of 24 equals x. Again, our goal, did we get x by itself? Look how we accomplished our goal. We got x by itself. Okay? At that point, guys, first step, you should have x solved for. Okay? Now figuring out what x is equal to is a little bit trickier. Now here, this is log base 6 of 24. That's not log base 10. That's not log base e. So that means we need to do change of base. So I'm going to have log of over log of. The base always goes to the bottom, so log of 6 on the bottom, 24 on the top. So we do some change of base. Log of 24 divided by log of 6. Go to my calculator. .774. Remember the question was 6 to the something is 24. 6 to the 1.774, 24-ish, right? So 1.774. Yeah, what am I expecting to see on this one? You got one more step because you got to do change of base. Okay? So rewriting again, right? And then evaluating. I know we're getting pretty close on time. We wanted to throw just a little bit of a curve at this, but this is a really tiny curve. If you look at 5 and 6 real quick, right? 4 is pretty much the same thing as 3. If you notice 5 and 6, like you should see some things you've seen before. You know, log of x minus 7 equals 1, or 4 times e to the x equals 20. Just this idea that these expressions need to be isolated before we can solve for them. And so if there's things on the side of the equal sign as those things, we just need to get rid of them first. It's a pretty common idea. You know, so if I have log of x minus 7 equals 1, I can't have that 7 there. So I'm just going to add 7 to both sides. And then once I have that, you know, that's just like number 2 or number 1 or whatever, right? It's the same thing. And the same way over here, 4 times e to the x equals 20. I just need to get rid of that 4 first. And I got e to the x equals 5. I can solve that equation really easily. Okay? So if there is one little thing to do, that's all we're going to do with you guys right now. Is just throw one little thing at you. You guys should know how to deal with that, and then move into the next part that we've been practicing the last couple of days. So, okay. So we did throw a couple of problems like that at you guys, but it shouldn't be a big deal to change it and then get it to what we've been working on. Okay. But I will finish those in when I post the video. So, okay. So if you need to go back and look at the end of the. Okay. So let's see if we can wrap up these examples real quick. So we got to log of x equals 8. We want to rewrite that into an exponential form. And so, you know, just remembering that it's log base 10 of x equals 8. So our base is going to be 10. So 10 to, you know, some power is going to equal some number. And that again is where our argument and our answer, those are the, you know, those switch places. So what we're going to end up with is 10 to the 8th equals x. So there's x solved for. So now what is 10 to the 8th equal to? So that's a 1 with 8 zeros after it. So x equals 100 million. So there's our equation. There's our answer. And then on 6, we had e to the x equals 5. I want to rewrite that as a logarithm. And so we know it's going to be log base something of something equals something. You know, what's our log base? So our log base is, well, since the base for x1 is e, our log base is going to be e. And again, I'm not happy that I wrote log base e there, but I'm going to do that for right now. And then that x and that 5, we're going to switch places. And so I know that it's log base e of 5 equals x, and don't want to write log base e, I want to write natural log of 5 equals x. So again, if you guys need to, like a little pit stop, say, oh, I'm going to write that, but I know Mr. Baker doesn't want me to do that, so I'm going to go ahead and rewrite it as this. You certainly can, but I'd really like you guys to go straight from here to here saying, oh, it's base e. Base e is always natural log. But we definitely do not ever leave it as log base e. We always rewrite it as natural log or go straight to natural log. So the natural log of 5 equals x. So I don't know what that is, but I know that my calculator can tell me. So function natural log of 5, 1.609. Or the question was e to the what? E to the 1.609. All right, it was supposed to be 5. Oh, there's something really close to 5. So see that it works. 1.609. So here's our equation. Here's our answer. And I'll go ahead and do that last example. 4 to the x equals 1.5. So I'm going to rewrite that as a logarithm. So log base something of something equals something. And the base of my logarithm is the same as the base of my power, so log base 4. And then the x goes to the right side, the 1.5 comes to the left side. So log base 4 of 1.5 is equal to x. So there we got x solved for. We just don't know what x is equal to because we're not sure what log base 4 of 1.5 is. But we know that we can rewrite it as the ratio of logs, common logs of and the base always goes to the bottom. So log of 4 on the bottom then log of 1.5 on the top. So then x is approximately, so log of 1.5 divided by log of 4. .292. So remember the question was 4 to the what is 1.5. So 4 to the 0.292 is supposed to be 1.5. There we see it's getting really close to 1.5. So pretty happy with our answer, 0.292. So this is what I'd be expecting to see from you guys. Your new equation, your change of base, and then your approximate answer. All right. Hopefully you're feeling pretty good about logs. I'm feeling pretty good about logs. I'll see you guys Thursday if I don't see you sooner. Be good.